Alright class, so here is question, well it doesn't say what question. Okay, question 36, but let me just go back to this page right here. So right here, there's nothing to answer. This is just an informational slide. So it says here directions, read the information and answer the questions that follow. So it says the principal at Washington High School investigated the relationship between student cell phone usage and student grade point average, GPA. The table shows a sample of the data collected by the principal. So we have this data. Let me go to the next part. So it's the same part here. So here's the question. It says select 2 questions the principal could have used to investigate the relationship. So because he is asking investigative questions, he wants to see the number of hours a student is using their cell phone and their GPA. So he could ask the students, what is your current GPA? Because that's this data right here. And how many cell phones? No, I don't think he needs to answer this one or ask this question. How long do you need to study? He's not measuring that. What was the last phone number you texted? Nope. How many minutes? Oops, let me see. How many minutes do you spend on your cell phone on a typical day? So these 2 are the questions because it's asking me to find the 2 questions. Okay? Alright, next one. It says the principal of Washington High School, so it's the same information. It says based on the data, so we want to see if it's a linear or if it's a quadratic. Well, let me go ahead and see what it looks like in Desmos. So here's my Desmos. I'll go ahead and plug the data in. You're going to have to kind of adjust to see how it will look. So to put the data in here, I will go ahead and press the plus button, a table, and I'm going to plug in my data. So just plug it in, 2.2, and then 2.5, and then so on. Once you have put in all the x values, go ahead and put the y values. Make sure that all of the data matches. Now, as I'm putting in the y values, you can see that the points are being added to that, right? So it's going 3.4. You can see that the data keeps going down, meaning that there's a decrease in how the points keep forming. And so on. 2 points. I'm just being very careful here, making sure that everything matches up. 2.6, 2.4. Oops, I put 2 comma 4. 2.4. 7.5 goes to 2.2, and then so on. So now, the more data I put in here, you can see that it is definitely a linear. A quadratic pattern, you would see the data going down and then somehow going back up. Okay, so but anyway, for this particular one, it looks like it will be a linear data. Alright, and then it says that specific data points show that, well, points to the right of the vertex. So this, when it says vertex, that's only for when you have a quadratic. So you remember a quadratic looks like this. So a vertex would be like down here, right? But it doesn't have that. So it cannot be a vertex. Actually, let me do it this way. I cannot have a vertex. Okay. This one also has vertex. The points follow a pattern that is consistent with more time spent on the phone, resulting in a lower GPA because the GPA keeps going down. Okay. Alright, so same data. It says the principal of Washington. It's the same information. The correlation coefficient of the curve of best fit is negative 0.99. this negative means that the points, just keep going down, but it is actually a strong relationship because it's a 99% chance that it is a linear. So the data is close together and it is a strong relationship. Okay, they're basically, the points are not all over the place and it follows a nice linear pattern. Alright, so this one, it says the same thing here, but it says the principal at Lincoln High School. So this one is another high school. The first one is Washington, and this one is a Lincoln High School. Collects data for his school and determines that the equation for the best fit is right here. So this is for Lincoln. I don't have the equation for Washington, but I can go ahead and build one in Desmos since I already have the table in here. I just have to do the linear regression. So y1 regressed against ax1 plus b. That's the linear one. So we have the a and the b here. So let me go ahead and write what the formula is for linear. So that is y equals, for Washington, let me write it here actually. It's going to be y equals a is negative 0.25, negative 0.25 x, and then the b is 4.16. So the y-intercept is 4.16. Okay, so here is for Washington High School, and then this one is for Lincoln High School. All right, now I think I have everything. It says the slope of the curve of best fit is steeper for Lincoln, or is it steeper for Washington? Well, let's see. Steeper just means that the line, it is, okay, let me go ahead and, so what I have here is for Washington, right? Let me change it to a blue so that I can keep things like that. So the blue one is for Washington, and then the red one will be for Lincoln, and then Lincoln is right here. So you have y equals negative 0.35 x plus 3.8. Okay, so let me change that color just so I can keep, so I'll just make it red. Okay, so you notice that the slope for the Lincoln High School right here is steeper than the slope for Washington. Steeper just means that it is going down faster, or you can see that it's going closer to the y-axis. Okay, so we can say that it's steeper for Lincoln. It says select 3 statements. Okay, so it cannot be this one. Let me mark that off. It can't be that. The student at Lincoln High School uses a cell phone at 0 hours, typically at 3.8. So this is just talking about the y-intercepts. So the y-intercept for Lincoln is 3.8. So that one is correct. Okay, so it cannot be the same for both of them. It is not. And then both schools, there is a negative relationship between the phone and the average number. That is true. It's not a positive relationship. It is a negative because, well, the more cell phone they use, their GPA is going down. So that's not a good relationship. Okay, and so it cannot be this one. There you go. And then the last question we have is, which conclusion about the relationship between student cell phone use and GPA best supports? Increased cell phone usage prevents students from getting good grades. It could be that, because grades do affect GPA, but in this particular one, we're actually looking at the more time students spend on their cell phone, the lower their GPA. So this is the better wording because we're actually looking at their GPA. Okay? Alright, using the quadratic curve of best fit, which equation most closely represents the data set? So I'm going to go ahead and put the data in here. So I'll put it as a table. So take everything off. I'm going to press the plus button, press the table. I'll go ahead and put in my values. So -8, -7, -5, and then 5, then it's a 3, and then 5, and then 7. All right, and then the next one. 38.6. .4. All right, so here is my data. It looks quadratic. All right, so I'm going to go ahead and put the quadratic regression, which is y1 regressed against ax1 squared plus bx1 plus c. All right, well, a is 1.7, b is 2.9, and c is -5.7. There you go. Okay, if you can't remember this, you can just, since it's a multiple choice, you can try your answer choices and see which one best matches it. You can also do it this way, okay? But I don't know. It's hard because, I mean, that one's good, but if you try other ones, like, for example, answer choice C, I think it's a bit close to it. So it might get a little confusing, but anyway, you can just try, but I would definitely go ahead and memorize the regression and then go from there. Okay, so it's D. All right, last one. The table shows the number of months used and the approximate distance driven in miles for 6 school buses in the district using the line of best fit. Okay, so this is a linear. So I'll go ahead and do the linear regression on this. 6, just type everything up. Once you have put the data in, obviously the numbers are so big, they're all the way up here. So I'm not going to zoom out or anything, but I will go ahead and put my linear regression. Okay, and then it's telling me after 40 months. So I'm going to have to type y equals a times 40 plus b. So it's about 91 for 26 right there. Okay, that's the last one. All right, question 31. It says the graph of the function f of x is shown on the coordinate plane. So this graph right here, it represents f of x. Okay, one thing that you should know is x is x and y is another way to say f of x. Okay, so this is the f of x, or another way you can think about it is this is your x coordinate, and this is, instead of saying y coordinate, I can call this the f of x coordinate. Same thing here, this is x and the y coordinate here is f of x, and so on. So this is also x coordinate, and this is, instead of saying y, this is the f of x. So the y coordinate is f of x. Okay, I know there's a lot of f of x here, but I just wanted to show you that that's what it means. Okay, which of these points is a solution to y equals 3 times f of x? 3 times f of x. So what I'm doing here is, for each of my y coordinate, I am multiplying it by 3. Okay, so 3 times 50 is 150. So the point would be 0, 150. Okay, I'm not going to graph it because I don't want to, but that's one of my points. The same thing here, I'm doing the other point for 1 would be 100 times 3, which is 300. For this one, 2 would go to 200 times 3, which is 600. Okay, so these 3 points right here are going to be on the graph of 3 times f of x. So let's see. 0, no, 1 goes to 300. So that would be the 1. Okay, it's a really weird question, but that's what it is. Okay, all right, let's go to the next one. Number 32. The graph of an exponential function, okay, exponential function, is in the form y equals ax a times b to the x power. Okay, contains the point 0, 2, 1, 1, and 2, 1/2, which is the best representation. So I need to just find these points. So 0, 2, 0, 2, it's right there, 1, 1, and 0, 1/2. Okay, there are my 3 points. Okay, well, all 4 graphs have all the points. So which one do I know is exponential? Well, it's going to be graph 3, C, because of the shape of the graph. Okay, you have to know what each of the graphs that we studied in Algebra 1 look like. So we studied linear functions. So linear functions look like this, y equals x. We studied quadratic functions, which is y equals x squared. They're parabolas. And we also studied exponential functions. I'll just put a to the power of x. Well, we need some value for a. I'll just put 10 to the power of x. So linear, what do you call it? Exponential functions look like this. Or let me make it look more like what we have in our answer choice right there, 1 over 10. Okay, so exponential functions do this, where they come down, either they go up or they come down and then just kind of flatten out. This one is coming down, but then it's going back up. That's why it will be C. This looks exponential, but you see how it's like going all the way down? No, it's going to go straight to the right. So that's what that is, exponential. Which table represents? Alrighty, it's just asking me to graph the function. So y equals x plus 5 to the power of 2. Okay, and then turn it into a table. And I'm looking at just 2 values here. I'm looking at 3 and 4, 64 and 81. Okay. All right, each table represents values of 4 different functions. Which table could represent an exponential function? So an exponential function, what happens here is, to get to the next term, you're multiplying by a number. Okay, so in this case, you're doing 10 times 10. So 10 times 10 is 100. We're multiplying by 10. And then 100 times 10, 100 times 10, and then so on. I'm going to show you a little easier way to do this. Okay, so an easier way to do this type of problem is, when you're trying to look for exponential functions, start with the last number, okay, and then divide by the previous term, and then the 1,000, and then do 1,000 again, and divide by the previous term. See how it keeps coming to the same number? So there you go. It's 10. What that means is 10 times 10 is 100, 100 times 10 is 1,000, and 1,000 times 10 is 10,000. So this is definitely a exponential function right here, table 1. And then the other one I'm just going to explore. Let's look at table number 2. So 1,600 divided by 900, 900 divided by 400, and then 400 divided by 100, and so on. See how everything is all different numbers? So this is not an exponential function. Okay, this is not an exponential, this is an exponential, and then it says which table. So I'm picking 2 tables. I just need to keep looking. Let's try table number 3. 500 divided by 1,000, 1,000 divided by 1,500. Oops. Two different numbers. I'm not going to keep checking. So it has to be table number 4. 625. All right. 1250 divided by 25 divided by 5,000. See how I'm multiplying by 1/2 to get to the next number? So table 4. So table 1 and table 4. Okay. All right, 35. Which function has at least one equivalent x-intercept? So the word equivalent means same x-intercepts. So I'm just going to graph them and just see which ones have the same x-intercepts. So f of x, let me just graph everything real quick. All right, so I graphed all of my functions, and we're looking for graphs that have at least one same x-intercept. It looks like the green and the red. So I'll take off the blue. So these two have the same x-intercept right there. Okay, so f of x and h of x only. All right, thanks guys. All right, a function f is described. So we have f of x here. The domain of f is all real numbers greater than 0. The range, so it's asking for the range. Okay, so for any domain and range questions, just plug it in Desmos and let's look at the graph. So x minus 2. Okay, so the range, it looks like it's at y, range is always y, greater than or equal to, so on the y coordinate it is 3, see? So range is y greater than or equal to 3. That's it. Which function does not have a y-intercept of 2? Okay, well, we're just going to graph everything and see which one does not have a y-intercept of 2. This one has a y-intercept of 2, so I'm going to cross that out because I want something that does not have a y-intercept of 2. This one also does. Okay, so I'll take that one off. Okay, well, this one also does have, so it must be the last one, but you know, since this is the SOL and I have all the time that I need, I will definitely make sure to check. Yep, this one doesn't have a y-intercept of 2, so it's that one. All right, number 28. All right, the function f of x is equal to x squared. So let me show you what x squared looks like. So f of x is equal to x squared. It's a parabola right there. And then we have another parabola here. Determine the transformation. So you can see that the transformation here is definitely going down. First, f of x was reflected over the x-axis. Y-axis would mean that it flipped this way, but it flipped upside down. So it's definitely a reflection over the x-axis. And the result was, is it a compression, stretch, and so on. It's translated up. Translated up because it the vertex moved up, even though it's going down, but the vertex moved up 1 unit. But we want to check if it's vertical stretch or a vertical compression. So a stretch would look like this. So f of x equals negative x squared, puts it down, and then a translated up would be up like that one. And then if I look at the coordinates for this, 0, oops, because there's too many. 0 goes to -3, here 0 goes, 0 goes to 1, 2 goes to 0. So I need this to be stretched out a little bit. Okay, it moved out. So it's definitely a, sorry, not stretch, a compression, because a compression makes the graph a little bit flatter. Okay, so 0.5. So what I can do here is just put 0.25, and then you can see how it's stretched out. I keep saying stretch, but it gets pulled out a little bit right here. Okay, so that's going to be a compression factor of 0.25. A stretch, like one of these, stretch of 2, would make it look like this. It becomes more narrower, but it did not get narrower, it actually got compressed. Okay. All right, next one. Drag the vertex to the current location. All right. Well, let me see what the function looks like. Oh, it's almost the same one. Right here. So I need to take the vertex and move it up a little bit to 1. Move it up to 1. And then the other point, it just wants me to put a point. So I'll put 3 and 1. So I'll put 3 and 1 right there. Okay. Given the function, all right, plot 3 points on the grid that would represent this equation. Each point must have coordinates that are integers. Okay, it's just asking you to put 3 points. That's pretty easy. We're just gonna find the 3 points in Desmos. Squared. What am I doing? Plus 1, and then turn it into a table. And then basically, when it says it wants integers, it doesn't want any of these decimals. I don't want decimals either. So I'm just gonna do -2, 2, 1 right there, 0, 1, 1 right there, and then 2, 2, that one. You can put any 3 points that you want. Oops. Anyway, I'm done. It has 3 points, and that's that. All right. All right, 21. It says select each function that has an x-intercept of 3. So it crosses the x-axis at 3. So let me kind of zoom out. So 3 is over here, right? 3 is right there. So I want to see which one has x-intercept right there. All right, so I'm just going to graph all my function and then check each one. All right, I graphed all of them, and I'm going to have to graph all of them because it says select each function, so it's a multiple select. So I'm just going to go through each one and just check which one has x equals 3. So x equals, nope, that one's not it. Nope. Yes. Nope. Yes, x equals 3. So there you go. These are my 2 answers. Number 22, let f of x equals x. I don't have it on here, but let me go ahead and graph it in Desmos. F of x equals x. So it's this graph right here. The slope is, well, let's see. For f of x, the slope for f of x is equal to 1, right? Because it's 1 over 1, 1 over 1. So the slope for f of x is equal to 1. So let me write it a different way. Okay, so the slope for f of x is 1. And what is the slope for g of x? G of x is, let's see, so it's up 1 over 2. So that's 1 over 2. Okay, so basically it's 1/2. The slope is 1/2 of the slope of f of x. Now let's look at the y-intercept. Well, the y-intercept for f of x is 0, right? So let me write that down here. So the y-intercept for f of x is 0, and then the y-intercept for g of x is let's see, the y-intercept for g of x is at 2. Okay, so this is not twice, this is 2 more. Okay, because twice, the word twice means twice means multiplication, but it's not being multiplied because 0 times 2 is 0, not 2. So it's 2 more is what I'm going to look for here. 2 more then. Okay. Alright, number 23. It says plot points on the coordinate plane. Okay, f of x is equal to x. The graph of g of x is 2 units up. So it's going to be the y-intercept is 2 units up. And then 3 times as steep. So the slope will be 3x. So that's 1, 2, 3 over 1. And that's about it. That's all I need to do there. Okay? Alright, f of x is equal to x and g of x is equal to 6x minus 1. Complete the statement to compare the graphs. So the graph is shifted up or down. Well, the negative 1 right here, it shifts it down 1. We can also graph it and check. So f of x and then g of x is 6x. It shifted, see how it shifted down? The y-intercept is shifted down, so it's down. And then the graph is steeper or less steep? Well, it's definitely steeper. Okay? Less steep would look something like this. Let me change the color of the graph so you can see the difference. Okay? So steeper looks like that. And then, oh, sorry, I should say less steep. And then steeper looks like that. And then less steep would be like a fraction. Okay? Alright, plot a point on the coordinate grid. A line and 3 points are shown on the grid. A line and 3 points are shown on the grid. The line on the grid contains negative 4, 7, so this point, and 5, negative 8, this point, and the point is located at 3, 4, right here. Okay. Plot another point with integral coordinates, just coordinates, on a line that passes through the point located at 3 points. It has to go through this point and is parallel. Parallel means it has the same slope. So let me go ahead and count the slope on this. So just pick 2 points. So that's down 1, 2, 3, 4, 5, and then it's 1, 2, 3. So the slope for this one is negative 5 over 3. And notice I'm using the TestNav app, so which is what you'll be using. Just use the pencil and count. So the slope is negative 5 over 3. So negative 5 over 3. So the same thing here. You're just going to count the same slope. Negative 1, 2, 3, 4, 5 over 1, 2, 3. So the other point will be here. So I'll go ahead and plot that point right there. And that's it. Okay, so if you want to erase your drawing, there you go. So there's my answer right there. You have to make sure to plot the point right there. You can either point like anywhere on a line that goes on here. So you can even point it up here, but make sure it has the same slope. All right, thanks guys. Alright, number 12, it says Michelle correctly solved a linear equation where the last line of her work is 1 equals 2. So when you have something like this, it's going to be no solutions, okay? So for the other ones, if the solution is 1, it would say something like x equals 1. If the solution is 2, it would say x equals 2. And then if it's 1 and 2, it would like look something like that. And then if it's infinitely, it would have something like 1 equals 1, or it would be like 2 equals 2, something like that. When you have two different numbers on both sides, it's going to be a no solution. Okay? Alright, the next one. Frank works at a convenience store. He earns $7.50 when he works during the day. And during the day is on the X. $12.50 per night is on the Y. he wants to earn at least 300 per week. So we just need to graph this in Desmos. So again, like I said, he earns 750 per day, and then 1250 at night. And whatever he works, he wants to make more than or equal to $300. Okay, that's what it is. And then what I'm going to do is I'm going to press the home button, zoom out, and this is the graph. So it has to go through about 24 and 40. It's about 24 and 40, but needs to be shaded above. So right there. Okay. All right. Drag the answer to the correct boxes. So we're basically trying to build this graph here. So what I want to do here is I'll go ahead and put these in. So I'll put y, and then I just need to, I'm just going to just guess. I'm just going to put less than because I don't really know at this point. And then I just want to look at the graph, and then I'll put y less than. I'll just start off with something. 2x plus 5 is less than y. Okay. Obviously, that's not the graph I have. I want the graph to be shaded over here. So I'm just going to mess around with these. So this one, I need it to be a dotted line. It's on the green. So let me change that to greater than. There you go. And then I have a dotted line and it's shaded above. This one just needs to be flipped up. So let me change this line and then put an equal to sign there. There you go. So again, the solution that I'm looking for is this area right here. Solid, dotted. There you go. So it's going to be greater than, and then greater than or equal to, and then greater than here. Okay. All right. Select the graph the solution set. So I'm going to graph this in Desmos, see what my solution set should look like. So you have y greater than 2 minus x. I need to graph that. Y less than or equal to 3x minus 2. I need to graph that over here. Okay, so first of all, I need a dotted line, and then I will graph, let's see, it's going from 2 to 2. So 2 and then 2. I need it to be shaded. I think I have to use this solution. Will be up here. Okay, so I just had to click it. The other line is from -2 and something like that. So I need to just pick another point. Let me pick that point 2, 4. So I'll do, for the next line, I'll do -2 and then maybe this point 2, 4. 2, 4 right there. Alright, I need to select the solution, so I want it to be over here. There you go. That's what I have. Alright, I think that's it. There you go. Alright, for this one, let me graph it. Y greater than or equal to 2 over 3x plus 1, and then 5x plus 6y is less than or equal to -30. Alright, my solution set is right here in area 2, right here. There you go, that's it. Alright, I need to find the solution set for this. I'll go ahead and use Desmos for this one. I'll plug it in. So you have 2x squared plus 4x minus 6. Zoom out, it has two solutions, and -3 and 1. So -3 and 1. Okay, that's it. The number of real solutions, so we're just going to graph each one and then just check the type of solutions they have. Okay, alright, let me just graph them real quick. Alright, well, let's look at each one since I have to look at all the graphs. So for this one, it has no solutions. I don't care about the y, I only care about the x. So this has no real solutions. The second one has also no real solutions. The third one has two solutions, right here and right here, only the x-axis. And then the last one is this one. It only has one real solution. That's it. Exactly 1, 0. So 1, 0 means one x-intercept. Okay, so we're just going to graph every single one and check. As I'm graphing them, you can look at the x-intercepts. Again, 0 just means x-intercepts. Okay, so we're looking for exactly one x-intercept. So let me look at the first one. This has 2 x-intercepts. I'm going to go ahead and cross that one out. Let me check the next one. This has exactly one x-intercept, so I'll pick that one. H of x has no x-intercepts, right? So this is also no. It has 0 x-intercepts. I'm looking for exactly one x-intercept. This one has exactly one x-intercept. And then the last one. 2 x-intercepts. I don't want that one, right? I only want one x-intercept. There you go. All right, a square with a length of x inches is shown. Okay, so this means this is x. So if it's a square, then you know all sides are all equal. So this is also x and so on. The equation y equals 4x represents the side length and the perimeter. So basically the 4x came from x plus x plus x plus x is 4x. So you have 4x right there. Which student states the correct domain and range? So whenever you have a domain and range, and when you're measuring something, so you have y equals 4x. The domain, even though it says looks like all real numbers and also range is all real numbers, it's actually only positive numbers. Okay, so says the domain is all integers. Integers are negative numbers as well. So that cannot be it. Stacy says the domain is all positive integers and range is all positive integers. It has to be that. It cannot be negative because I cannot have negative lengths, right? And then domain is all positive and range is all positive. No, it cannot be all. Wait, maybe that one. Hold on. Marlon says domain is all positive integers. Oh, real numbers. So real numbers, the difference between real numbers and integers is integers are just just a little tick marks you see here. So basically 1, 2, 3, 4. Real numbers are actually decimals as well. So actually it's going to be Marla is correct. Real numbers. Okay? Integers doesn't include decimals, but you can have decimals when you're measuring, right? So yeah, that's that. All right, question number 1. It says here, what value is this expression? So you know what? I'm just gonna plug it in exactly the way I see it. I'm gonna first go ahead and assign the numbers. Okay, and then I'll go ahead and type it in exactly the way it is. So 5 cube root is over here. Cube root of a minus c square root of b plus 9 says 35. That's it, you guys. Okay. When completely factored, so whenever it's asking you to completely factor and pick all the factors, just go ahead and first find the GCF between all the numbers. So between 9, negative 39, and 30. So the GCF is 3. And then the other part, you're going to go ahead and match up the x-intercepts. I feel like I've done this problem so many times. You're probably sick of seeing me do this. But anyway, these are my factors. So I'm just going to type everything in and then find all of the ones that have the same x-intercept. There will be double factors in here, and I'll show you how to eliminate the ones that look like a factor, but they're actually not a factor. Okay. So this is, so let's go through each one. So that looks like a factor because I have the same one, but you see how this one has the GCF 3 in it, so 3 and then 5 here, because 3 times 5 is 15. So I cannot choose this one. because it has the GCF in it. This one also has a GCF of 3, so I'll take those two out. Now I'll find the remaining ones. You can see that one also looks like a factor, but they're not. This one is not a factor because the x-intercepts don't match. This one is a factor, so I'll pick that one. And then this one is the other factor, x minus 5, and then this one is not. Okay? All right, quotient. So when we're looking for a quotient, it just means it's a division. So on the numerator, I'm putting 5x squared minus 8x minus 12. And then in the denominator, 3x plus 2. That's my quotient right there. I'm going to graph it for you, and then I'll just graph the answer. So I think it's the last one. See how it's the same exact graph? That's about it, you guys. That's all I want to do right there. Okay? All right, select the 3 equivalents. I'm going to graph all of them and select which 3 have equivalent graphs. Okay? All right, let's check each one. All right, so there's my original. Is that the same graph? Yes, it is. That one, nope. That one, nope. Yes, yes. So these are the 3 ones. So the first one, and then the last 2. All right, simplest form, so I can actually just graph everything in Desmos and find the simplest form. So when I see a variable in my question, variable in the answer choice, I like to match them up, but because it has an x, it's graphing something for me. I want to make sure that I plug in a number for x. I'll show you what I mean. Okay? Actually, let me just graph this, so it should be fine. Whoops, what is this? Okay, and then I think it's the last one. See, it's the same exact graph. If you want to go ahead and change this to like an actual letter and then plug in a random number, that's fine too. Okay, so like I can plug in just some random number and then match up the numbers as well. Okay? All right, next one. Hope we know how to do this in Desmos. So we're just simplifying this. I'm going to put 180. You guys are great at this. 180 divided by x squared. Because it's a square root, I'm going to put x squared. Turn it into a table. Enter, enter, enter. So that looks like it simplifies down to 6 square root of 5. So it's going to be 6. Let me take that off. 6 square root of 5. Okay. All right. Basically, we are looking for equivalent. So cube root of what number? So 35. Let me try it. Is equal to this. I know you guys know how to find the cube root, but I'm just going to do it a little faster like this. See how they don't match? So let me change 35 to 245. They don't match. 875. Yep, that one matches. Okay. Simplest form, I can match them. Yeah, let me just match them. Cube root of 3, 4, 5, 6. You don't need the comma. I think it's this one. Cube root of 2. Yep, that's the one. You can match them up. Or if you want to do it the other way, 3, 4, 5, 6 divided by x cubed this time. Turn it into a table of values and then go down. And so that's going to be 12, 2. 12, 2. All right, number 9. So for this one, what you want to do is you want to multiply the outside first. So 4 times 2. 4 multiplied by 2, which is 8. And then square root of 2 times 3, which is 6. So, and that's that. 8 square root of 6. All right, this one is easy. Just kind of graph it in Desmos. So plug everything in Desmos. Negative x plus 4 minus 2 is greater than 2x plus 6. So it's going from negative 4. It's an open circle because it's a dotted line and also because it doesn't have the equal to. So it's an open circle. And then it starts at negative 4. and then goes to the left. Alright, same thing here. I'll just graph everything. 6x minus 11 minus 13. X is less than 7 minus 5x. Make sure you type everything correctly and then zoom out. Negative 9. So you have, this is actually going to be x greater than negative 9 because it's going to the right. Right. All right, guys. Thank you.